first thing we can use these identities for is to find the exact value of trig expressions of angles that are not in our special right triangles. So, for example, if we want to find cosine of 15 degrees. In the past, we wouldn't have been able to do that. What we can do now is split this up, where we know 15 degrees is 45 degrees minus 30 degrees. So now we can use our difference cosine formula and let 45 be A and 30 be B. So the difference formula for cosine is we have cosine of A minus B, and all these formulas are on the previous slide, and we get cosine of A, cosine of B, plus sine A, sine B. So now we just need to plug our angles in. So we get cosine of 45, cosine of 30, plus sine of 45, sine of 30. And this is why I had you guys kind of recap on the unit circle earlier this week, because here's where we need this. We know cosine of 45 is radical 2 over 2. We know cosine of 30 degrees is radical 3 over 2. Sine of 45 is root 2 over 2. Sine of 30 is 1/2. So now we just multiply across, simplify. Root 2 times root 3 is root 6. 2 times 2 is 4. Remember, with fractions, you just multiply straight across. And then root 2 times 1 is root 2. 2 times 2 is 4. And lastly, they have a common denominator. Naturally, that will happen. So we get root 6 plus root 2 all over 4. And that's our final answer. So now, tangent, as you can already tell in the formula, by nature is going to be a little bit messier than the sine and cosine, but it's still the same process. So we want to find tangent of 7 pi over 12. Well, first off, when we're dealing with radians, it's a lot easier to see how degrees can add up. Keep in mind the angles that we know. We have pi over 3, pi over 4, and pi over 6. So in order to get pi over 12, we need to get a common denominator among these. We know pi over 3 is the same as saying 4 pi over 12. Pi over 4 is the same as saying 3 pi over 12. Pi over 6 is the same as saying 2 pi over 12. So just whenever we're doing these sum and difference with radians, you're going to have to be converting to twelfths. So now it's easier to see. For tangent of 7 pi over 12, we want to rewrite that to be tangent, and we know 4 plus 3 is 7, so if we do 4 pi over 12 plus 3 pi over 12, we get 7 pi over 12. But we want to use the angles that we're used to, so this is going to be pi over 3 plus pi over 4. So now, same thing as before. Pi over 3 is our A, pi over 4 is our B. It's just a matter of plugging into this formula. So we're doing a sum formula. The tangent sum formula is that tangent of A plus B, just that we have it in one spot, is tan A plus tan B all over 1 minus tan A tan B. So it's just a matter of plugging everything in. We need to do tangent of pi over 3 plus tangent of pi over 4 all over 1 minus tangent of pi over 3 times tangent of pi over 4. So now it's a matter of using our unit circle values, plugging those in, actually evaluating these trig functions. So tangent of pi over 3, we know tangent is y over x. Pi over 3 is the top one, so y is root 3 over 2. X is 1/2. So this turns into root 3 over 2 times 2 over 1. So we know tangent of pi over 3 is root 3. Tangent of pi over 4, that's root 2 over 2 divided by root 2 over 2. So that's just 1. So if we put this all together, we get root 3 plus 1 over 1 minus root 3 times 1. Yes, these are messy, but it's just a matter of plugging and chugging, rationalizing, so forth. So we get to the bottom we have root 3 plus 1 over 1 minus root 3. Here's where we need to remember our skills from last year. To rationalize this denominator, we have to multiply by the conjugate, which we just talked about with proof. So the conjugate of 1 minus root 3 is 1 plus root 3. Multiply that across, FOIL all this out, and we get root 3 plus 3 plus 1 plus root 3 all over 1 minus 3. Remember, the whole point is to have a difference of 2 squares there. And just about done. 3 plus 1 is 4, plus 2 root 3 all over 1 minus 3 is negative 2. Reduce this by dividing that negative 2 out. And we get negative 2 minus root 3. So, tangent is the same idea as sine and cosine. The formulas do end up messy, but it's going to be the same process each time, where you're multiplying by a conjugate, simplifying your radicals, reducing a fraction.